Yeah, so Web of Science Group started over 60 years ago with our original name of ISI. So if you ask any of your senior researchers within UMT, if they say, oh, I published a paper in ISI, that actually refers to our own name, ISI, that means Institute of Scientific Information. Okay? It's very important to remember this abbreviation because there are many predatory websites as well as journals out there that indicate that they are ISI, but if you actually search in the Web of Science platform, they do not actually exist on our platform. All right, so just remember ISI stands for Institute of Scientific Information. So over 60 years ago, our founder, Dr. Eugene Garfield, started with ISI. And over the years, we changed names as well as changed companies to Thomson Scientific, Thomson Reuters, and currently, as of today, we are Clarivate Analytics. So Clarivate Analytics has multiple arms. We have the intellectual property arm as well as the science arm. So under the science arm, this is where the Web of Science Group sits. And the platforms like Web of Science platform, journal citation reports where the impact factor sits, as well as insights, benchmarking, and analytics, and EndNote desktop applications, and so on. These sit under the Web of Science Group. Okay. So on the screen now, I have 4 words that probably most researchers have a feeling or association to. Okay, so as we go through these 4 words, I want you to, in the back of your mind, think of what each of these words mean to you as a researcher. So the first word is time. What does time mean to a researcher? In my experience, speaking with multiple researchers in the region, most of them tell me that they have not enough time to sleep. Or, for example, they don't have enough time to do their research properly because they need to hand up tutorial homeworks and case discussions and so on and so forth. Even then, as a researcher is not your full-time role. You would probably be a wife, a husband, a son, a daughter, and so on. So time is of the essence for you as a researcher or postgraduate student within UMT. What about the second word? In terms of accuracy, okay? When you do your research in terms of measurements, taking volume measurements, and so on, your data has to be accurate. Okay? What about novelty? Why do you want to do research? The reason why you want to do research is probably so that you can discover something new that will be beneficial to society, to the environment. So that leads us to the 4th word, which is impact. Whatever research that you do or publish, you want to have citation. You want to have at least somebody use your research to further science in that area. Okay? So these 4 words kind of portray the all-encompassing roles for a researcher. Okay? And that is how the Web of Science has been built. Okay? So on the screen today, on the screen now, you would see an example of a full-text research paper. So most of the time, the research starts from a eureka moment when you read an article. Correct me if I'm wrong, okay? But you always start with a full-text paper to get a kind of idea of where you want your research to go or what topic you want to research on. Okay? But research will not advance with just one paper. To build your own research and do a robust research for your own paper or manuscript, you would probably need to do a lot of literature review. Okay? So when you do literature review, most of the time you will want to find more related papers. But the problem with limiting yourself to this one full text paper is that this one full text paper only highlights older papers in the reference list. Okay? So how would you find newer papers? So I'll answer your question. I'll answer the question later on. Okay, but first I want to show you this list of words. Okay, I have 3 words on the screen: water spinach, kangkong, and bakpong. Okay, some of you would recognize at least 2 of the words. Okay, because these 3 words are actually referring to the same plant. Okay, so kangkong can be named water spinach. Okay, and bakpong is the Thai word for water spinach. Okay, so in terms of keyword searching on full text databases or Google, sometimes you might be limited if you say you search for water spinach. You might miss out on research papers that mentioned bakpong because of its locality. You might miss out research papers mentioning kangkong because these would have been maybe mentioned in Indonesian or Malaysian journals. Okay? So keyword searching is good, but it has its limitations. Okay? So in order to address these 2 issues, the first issue of finding newer papers, as well as avoiding missing papers from keyword searching, okay, you can explore a citation index. So the Web of Science platform is actually a citation index. I think all of you would know what is a citation. So when you put in a reference in the paper, that is 1 citation. Okay? So what we do in Web of Science platform is we index cover to cover each article's title, abstract, as well as the reference list and the keywords. So because we index every single reference that is on that paper, we are able to link different papers together based on their citation relationships. Okay? So this is the power of the citation index. So how does it work? Imagine this on the screen here is your first paper in the middle, okay? And you look backwards at the reference list for older papers. But because you're in a citation database, you're able to see what newer papers have cited this original one you were looking at. So therefore, you get your newer papers on the right. So the papers on the left would be what we call the backward citations, where you look at cited references. And on the right would be the newer papers, which would be the citations that have cited this original one. And because we have indexed all references in all papers, we are able to do some kind of matching where we are able to look at papers that have shared references. So they might not have cited each other, okay, but out of, say, 10 references that they have, 3 of them are similar. They share 3 same references. This would mean these are related records, but they might not have cited each other. Okay? So these 3 ways is how you can build on your literature search within Web of Science. So on the left, you have your older papers. On the right, you have your newer papers. And on the bottom, you would have your related records. That could also be important when you explore your research topic. Okay? This is an example of one record within the Web of Science. Okay? You would see the title. Okay, let me just try this one. Okay. Okay. So you would see the title, the authors, as well as the journal it has been published in. And because University Malaysia Terengganu has access to journal citation reports, you're able to see the journal impact factor of the journal within the Web of Science. Okay? And you also see the abstract as well as keywords. Okay? On the right, you will always see the citation network, where we give you a link to new papers, which is under number of times cited. So if you click on that number, it will take you to the newer papers. This number 45 here would be a link to the reference list for this original paper. And one thing to note about the reference list in Web of Science is that it is more powerful than looking at the full text paper's reference list itself. Because if you remember, on a full text paper PDF, in the reference list, will you see the time cited for each and every reference on that list? Probably not, because it's stagnant. On Web of Science, because we index all papers and all references, you're able to see the time cited next to each and every paper in this 45 references here. Okay? So later on, when I take you through the demo, you will be able to see what I mean. Okay? So this illustration here is an example of how using a citation network like Web of Science can help you to discover what has happened in this research field over the years. Okay? Say, for example, you started with a search of a 1979 paper around sodium heparin. And this paper was cited by a 1996 conference proceeding mentioning about low molecular weight heparin. And you explore the citation network further, and you found another highly cited paper in 2015, which is only about 5 years ago, okay, around venous thromboembolic disease. Okay? And you can see that this topic has kind of evolved from a pure chemistry topic around sodium heparin to a disease around venous thromboembolic disease. So how is this two connected? They are probably connected based on the therapeutic aspect, meaning sodium heparin might have been used in the treatment for venous thromboembolic disease. So it's because you're able to link through in a multidisciplinary citation index like Web of Science, because you're able to see the connection between these papers, and it doesn't limit you to one discipline. Okay? So that's how you can see how this chemistry topic has evolved into medicine. And from the 2015 paper, if you want to continue exploring, you can look at the reference list again and go back to look at the older papers. One thing to note is that the Web of Science is not a full text database. Okay? So you will not be able to retrieve full text papers from Web of Science unless it is an open access paper, meaning it's free to view, or UMT library has a subscription to that full text. Okay? We will provide you the links out to the publishers' websites as well as open access resources, okay, so that you can retrieve the relevant full text with permission. Now on the screen now, we have 3 pictures. So we have sands, stars, and journals. What do these 3 things have in common? Okay? You can't count. You can't count sand, you can't count stars. Well, maybe you can count journals, okay, unless it's a full-time job for you to count journals. Because I think there are at least millions of journals out there, both English and non-English journals. And every month, I think there are new journals coming up as well. So imagine this. If you are a postgraduate student, you probably have 3 years within UMT to do your postgraduate studies. Within these 3 years, you are probably expected to publish 2 papers, I'm assuming. Okay? Some universities publish 1, some universities publish 2. In UMT, I'm assuming you publish 2. So within 1 year, so let's say 1 week, how many papers can you read? Most researchers will answer that they can probably fully read 1 and understand it. So 1 paper a week. So it takes them one week to read 1 full paper. Okay? So in 1 year, you have 52 weeks. So that would mean that ideally, you have opportunity to read 52 papers in a year. So how many papers are there now in the world in your own research topic? Probably millions as well. Okay? So how do you select that key 52 to read from these millions of articles? Okay? So that's how Web of Science was built. We have made a study. We did an analysis on about 12,000 journals. Okay? And we found that only 2,400 journals had the majority of citations, meaning you only need a small number of journals, but you need to select the correct ones to read that give you the impact and citations. Okay? And that's how the Web of Science core collection was built. This is an overview of the Web of Science platform. Okay? On the platform itself, we have many different citation indexes. The Web of Science core collection, which is in the center of this wheel, okay, this is curated by Clarivate Analytics Web of Science. Okay, so the Web of Science core collection comprises of the Emerging Sources Citation Index, Science Citation Index, Social Science Citation Index, Arts and Humanities, Conference Proceedings, and Book Citation Indexes. Okay, so all these form the core collection and is curated in-house by Web of Science editors. The ones on the outside of the wheel. Okay, can all of you hear me? Because I received a chat from Rohana. She said she can't hear. If you can hear me, can you please acknowledge in the chat box that you can? Okay. Okay, great. Rohana, maybe it could be an issue with your speaker. So maybe what you can try to do is check on the icon, the speaker icon on your computer, and see whether that has been turned off. All right. Otherwise, if you still can't hear me, don't worry. The session has been recorded, and I'll send it across to everyone after this. Okay, so back to the session. Okay, so on the outside ring, those are citation indexes that are not curated by the Web of Science, meaning they belong to external bodies, and they would be the ones who are evaluating the journals and indexing in those databases. Okay. For UMT, University Malaysia Terengganu, this is something new for you this year. So you just started, the library has started subscription for you to access also zoological records. Later on, when I do a demo on Web of Science, you'll be able to see why it's so powerful to include these zoological records into your collection. Okay. Okay. So just I want to just quickly go through this particular slide because I know for a lot of researchers there is confusion around which citation index has impact factor, which does not, and so on. Okay? So as I mentioned earlier on, the Web of Science core collection includes science, social science, arts, humanities, emerging sources, books, and conference proceedings. So everything here on this screen is the core collection. Okay? And some of you would ask me, so if the journal is in ESCI, does that mean that this journal is lousy? No, it doesn't mean that way. Okay? There's a reason why Emerging Sources Citation Index exists. Okay? The reason is because when a new journal wants to be indexed in Web of Science, it will go through an evaluation process. So this evaluation process involves 24 quality criteria and 4 impact criteria. If this new journal fulfills all 24 quality criteria, it will sit in Emerging Sources Citation Index, which is ESCI. If it fulfills an additional 4 impact criteria, it will be promoted up into the flagship 3, which is the science, social science, or arts and humanities. Okay? So to make it easier for you to remember, Olympic Games is coming up. Okay? So all of us can't participate in the Olympic Games except if we are an audience. Okay? But as a participant, as a representative of a country joining Olympic Games, you are considered a qualifier. So if you're a qualifier, this is equivalent to ESCI. So the qualifying journals are your ESCI journals. Then the journals will start running the race. Okay? And for each discipline that they run in, if they get the gold, silver, and bronze medals, for example, this gives them the benefit of promoting up into science, social science, and arts and humanities citation index. So that is how you can try and remember the differences between these different indexes. Okay? So as the name suggests, science is science, social science is social science, arts is arts and humanities. ESCI covers all subjects. Okay? So that is something that you would have to remember very clearly. Okay? Another good thing about Web of Science is we have access to a lot of open access articles, meaning we have worked with Impact Story. We gave Impact Story a grant, okay, to go through all the open access resources out there in the world and indicate down to the article level which articles are open access. Okay, we have different levels of open access, which is the bronze, green, DOAJ gold, green accepted, and other gold. Okay, if you're interested to find out the main differences, okay, I'll send you a link later on. Okay, and but ultimately, as a researcher, you just need to remember open access equals free to read. Okay. So now I'm going to have a quick look at the chat box to see if there's any questions. Okay. No. All right. So now what I will do is I'm now showing you the Web of Science platform on my computer. Can all of you see this? Okay, great. So for University Malaysia Terengganu, your access would include the Web of Science core collection, which is this one here, as well as zoological records. Okay. All right, so all of you would have access to the Web of Science core collection, okay, as well as zoological record. Okay. You can see that many databases here. Okay, just ignore this because I have full access to everything. But for UMT, your subscription is Web of Science core collection and zoological records, and I think possibly the let me see, Korean, okay, the Russian, and Cielo citation indexes. Okay, these 3, 1, 2, and 3 are the regional indexes, meaning if you're interested to look at the Korean output, Korean journals, go to Korean journal database, Russian, and Cielo is for the Spanish, Portuguese literature. Okay. So because you have access to zoological records, my recommendation is when you do a search for Web of Science, click on all databases. Okay. So when you click on all databases, you will be searching both the Web of Science collection as well as zoological records at the same time. Okay. So for today's interest, I'm actually going to just search for coral reefs as my topic. So this is how you start searching. You can add in any rows to build your search string and change this to N or not to adjust your search. Okay, just going to reset this. I'm going to do coral. Okay, and start a search. Okay. So as you can see here, we have 42,000 results because I basically searched all years, meaning from 1924, I believe, okay, till to date. So that is a very big number. So what you can do is, on the left, you have a few things you can do to refine your search a bit. So you can select the years. So let's say 5 years here and refine. This would bring down your results significantly to about 9,000. Again, this is very far from the 52 papers, right? So how do you choose these 52 papers from this list? On the left, you see the trophy logo and the fire logo. For UMT, you have access to this because of your subscription to JCR and Insight. So if you're looking for something that is highly cited in this field of coral reef research, you have 100 papers, and you can just select this trophy logo and refine. Okay. And all these 100 papers will be your highly cited papers. In this list, you would see also some hot papers in the field. So there are 4. This would mean that up to today, it is still considered very relevant and a very hot trending research paper. Okay? And you can click through to this record to have a look and see why. Okay? So let's look at this record. So on this list, this record here, you will be able to see the number of times cited. Okay? Okay. The number of references here on the right, 88, as well as some keywords. Now, keywords plus, this one, keywords plus, this is unique to Web of Science because when we index all the papers together, we also index their keywords suggested by the authors. So these keyword plus are additional keywords that we find are mentioned together when we are talking about this area of research in this paper. So it could be used to limit your search results down to something a bit more manageable. Okay? So you can feel free to use any of these keywords to refine your search further. Okay? Having a look at the cited references here, as I mentioned earlier on in my slides, I said that we include the time cited next to the reference list. So that is one key difference between the full text paper and the Web of Science record. We give you the time cited for each and every one of the references here. Okay? Sometimes as you scroll down, you might see that there are no links. Okay? So this particular reference, for example, there is no links. This would mean that it is currently not indexed in Web of Science, but because it is a reference in this paper, we will still include it in. Okay? If you want full text for this paper, you can just click on full text options and link through. Alternatively, if you see this green logo here, this is Copernio. You can search for Copernio later on, K-O-P-E-R-N-I-O. Okay? And this is a tool or plugin that you can use on Google Chrome or Firefox. And what it does is it will search through open access resources. It will also search through your library's resources. And if there is a full text available in PDF, immediately you would see this green icon here. And if you click, it will open up the full text in a separate window. So you don't have to research and go and figure out a publisher's website and so on. Okay? So let's go back to the search results. Okay? So from all these papers, these are how you can shortlist your reading list. So if you choose these first three, you can add it to your marked list for your future reading. So once you click add to marked list, you see this number 3 here, means you have 3 papers here. So as you go through your literature review for your own research, okay, I would recommend that you save 1 list per research topic. Okay? This will help you to manage your reading literature search a bit better. Okay? Now, so this is an overview of finding the papers to read. Okay? Hot papers are your trending papers. Highly cited papers are your classic papers that are important to read in this research area. Okay. Now going back to the search box here, the search page, I want to show you the power of using zoological records. Okay. If I were to search just Web of Science core collection, so I'm switching back to Web of Science core collection, and I'll search for the topic of coral reef. This gives me only 30,842. But because you have access to zoological records, okay, if I go to all databases and I search for the same thing, coral reef, this gives me additional papers to read. Okay, so that's a significant number of additional records that you can look at. Okay, if you are interested to find out what is unique to zoological records, you can limit to zoological records here on the left, refine. So these 29,000 papers are papers that are in zoological records. Okay? And out of these 29,000, okay, what I'm going to do is I'm going to take out the overlap, meaning I want to show you only unique zoological records data. So unique to zoological records, you have 8,257 records on coral reef. So this is a substantial number of additional content for you to look at. Okay? So this is my very quick overview of Web of Science core collection as well as zoological records. Okay? Are there any questions from the audience? Okay. I don't see any questions from anyone. Okay. If yeah, I'm going to show my slides again. And all of you see my slides now? Okay. So if you have no questions, at the end of the session, I will show you my email address. Okay. You can send me an email about questions that you might have while you start using the database. Okay. Someone said, can you show again about marked papers? I don't really get it. Okay. So marked papers are something like your bookmarks. So if you bookmark any record on Web of Science, okay, so let's say for example here, let's say you want to keep this record for your own reading later on, you can select this and add to marked list. So this is like your bookmark. Okay, so you bookmark this and then you come back to that list later on. Okay. Okay, there is another question. When I enter WAS via UMT, it says roaming privileges have expired. Okay, so for this question, because now most of you are not on campus, so what I would suggest you to do is, I believe UMT would have an easy proxy access to the library for remote login. So you will need to go through your library's portal, sign into their easy proxy so that you can access all the library's content. Okay? So because you're working from home or studying outside, okay, you would need to do this one more step before you enter Web of Science. Okay? So there's one more question about what is the difference of highly cited and hot reference. So highly cited, so these two. So highly cited in field would mean that these are, let me just click on this. You can read the definition. So highly cited papers are those that have received the top 1% of citations for their field between November and December of 2019. Okay, so these are highly cited papers. Okay, and hot papers are those that are in the top 0.1% in terms of citations between November and December. Okay, but these hot papers would be referring to only papers that have been published in the past 2 years. Okay, highly cited papers would include papers from past 10 years. Okay, so that's the main difference. Okay, another question, does article search pertain to library subscription? Yes, so the article, so for your full, the article search here, the search results does not require a subscription by the library for the full text. Okay, but for you to click through and access full text, you will require a library subscription. Okay, so on Web of Science, you can see the abstract, the author's name, the citations, and so on, but not the full text paper, unless there's a subscription by the library or it's open access. Okay, how can we connect that the paper that I've searched to insert in my Mendeley? So if you're interested to include this into your bibliometrics management tool, there's an export function here. So you can click export. Okay, if you are using EndNote, you can send it to EndNote Desktop or EndNote Online. If you have other references, you can go to other file formats. Okay, other file formats, and then you can export this under other reference software, and you can open Mendeley and then just port it over. Okay. 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 So if there are any more questions after this, feel free to drop me an email. Okay. But the next session we have would be on Wednesday, which is the 25th of March at 2:30 in the afternoon. For that session, I'm going to cover how do you identify quickly the Q1 to Q4 journals for your own specialization. Okay, so this might be of interest to all of you. Okay, so if you haven't registered yet, this is the QR code as well as the link at the bottom of the slide. Okay. Okay. And then on the 6th of April, we will have another session around how do you identify collaborators for your own research and ensure that you have a good public profile so that everyone can contact you if they want to collaborate with you. Okay? So this is happening on the 6th of April, which is a Monday at 10:30. Okay? And the registration link is here. Okay? And this is my email address in case you have any further questions for me. I see that there's one more question from the group. Okay, what is the main difference between Web of Science and Google Scholar? That's a very good question. Thank you. Okay, so Google Scholar, I believe, indexes every single journal or content out there. There isn't a very clear idea of how they choose to index journals. But for me, for Web of Science, what we do is we only index up to 21,000 journals as of to date. So I think slightly more than 21,000 journals. So we do not index every single journal, but we go through a very strict selection process before we allow a journal to be indexed in Web of Science. Therefore, this ensures that what you're reading is of good quality and good impact for you to use in your own research. Okay? And one more. How about the 31st March? Okay, I think there is a 31st March. Let me see. Oh, I might have missed out the 31st March. Okay, let me just show you the picture. Can you all see this picture? Okay, so this is the QR code for the 31st. On the 31st, I have a session at 11, and this is on how to identify good journals to publish in that will be suitable for your manuscript. Okay, so this is the QR code that you can take down. Okay, and the link is also on the poster, and I believe it is session. So it's the same URL. Okay, I'm just showing you the screen here. Okay. Okay, so these are all the 4 sessions that are happening. Okay, so the 31st is at 11, 6th of April is at 10:30. Okay, so I hope you found this session useful. Okay, and I hope to see all of you in the next one. And do stay in touch and please stay safe. Okay, thank you.